Yes, dear students, now I want to explain here the series combination resistance. Though you know about this combination from class 10, but there it is simply tell equivalent resistance is sum of the three. But how it is there? Here current three resistance. These are conductor. I told you in last video that the conductor is generally called resistance because it offers resistance. So R1, R2, R3 are the resistance of three conductors connected in series across battery of V volt. In this combination, current through each will be same. Electric current same होगा. So from Ohm's law, potential difference across the conductors are given by V1 equal to IR1, V2 equal to IR2 and V3 equal to IR3. But from figure, total applied voltage is sum of three voltages. V equal to V1 plus V2 plus V3, or V equal to IR1 plus IR2 plus IR3, or V equal to I bracket R1 plus R2 plus R3. Total voltage is given by this. Now, what is our purpose here? Our purpose is there that which conductor should be connected across the same supply so that we can draw current I. That is, we need to find equivalent resistance of combination. The meaning of equivalent in books, actually, even in NCERT book, they have written total resistance. Okay, it is here total, but somewhere that is not total word. This is equivalent. Equivalent means if we connect here a conductor which takes current I at V volt, then that is called equivalent. I am a teacher and you are a student. There is lot of difference in our age. There is lot of difference in our height and so many things. But if you can do the same work as I can do, then you are equivalent to me. This is the meaning of equivalent. Actually, people are confused with the word equivalent. Literal meaning should be known. Actually, we don't understand the meaning and we keep on guessing other way. So if capital R be the resistance of a conductor which can draw current I from a supply of V volt, then we can write V equal to IR. If R be the resistance of conductor which can draw current I from, say, supply of V volt, then V equal to IR, and here R is called R is called equivalent resistance. Equivalent resistance of the combination shown in figure. So comparing equation 1 and 2, we get, comparing 1 and 2, equation 1 and 2, we get R is equal to R1 plus R2 plus R3. So in series combination, equivalent of series combination is equal to sum of the resistances. We can say, so people started saying total resistance. This is equivalent. So in series combination, you can write yourself, in series combination, equivalent resistance of the combination is equal to the sum of individual resistances. In series combination, current remains same, potential get divided, potential difference get divided while current through each remains same. Now I come to parallel combination. Parallel. Please understood the word meaning. I mean, parallel combination. People have deleted the syllabus, but deleted syllabus has a relation with the main topics which are left with us. So please, dear student, work hard and learn all things which are given in old syllabus. Don't go on, if total chapter deleted, that is another thing. But if I have heard that series combination, parallel combination have been deleted, but questions are there and they are asked in the board exam as well as competitive exam. So series combination is shown like this. I mean, here we can show it like this. Moreover, in coming future, you have to learn so many things. I mean, and apply the same. In technology, you want to be engineer and you don't know the basic knowledge, so you will be trapped and there will be lot of problem. R1, R2, R3 are the resistances of three conductors connected in parallel. Here, if we close this key, so we put a dot and current start flowing. Current I, it will get divided. So sequentially we take, let this current be I1, here be I2, it be I3. I mean, now it is I. So figure shows parallel combination. Here potential difference across each conductor is same. So from Ohm's law, current through the conductors are given by I1 is equal to V by R1, I2 is equal to V by R2, I3 equal to V by R3. I hope you are getting it. Potential difference between these 2 points equal to this V volt of battery. These wires are supposed to have zero resistance. Connecting wires are here. Thick wires and their resistance supposed to be zero. Supposed to be zero. Hota nahi. It is not zero. But we have supposed. So total current drawn from battery I equal to I1 plus I2 plus I3. Or I equal to I1 V upon R1, I2 V upon R2, I3 V upon R3. Or I equal to V common bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is equation 1. Now if we use single conductor instead of 3, if we use a single conductor instead of 3, which takes current I from the same battery or cell battery or cell, then the resistance of the conductor will be equivalent to the combination, and then we can write I equal to V by R. Comparing again 1 and 2. Comparing 1 and 2 again, we get comparing equation 1 and 2, we get 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So what do we say here? What can you say? Reciprocal of equivalent resistance equal to sum of the reciprocals of individual resistances which are connected in parallel. In parallel combination, here you can't say R is the total resistance, whether it is series or parallel, but I don't know why the different authors started writing like that. I have a strong objection to this. It is equivalent, not total. It is equivalent. So what is the equivalent? Reciprocal of equivalent resistance of the network equal to sum of the reciprocals of 3 resistances connected in parallel in the network. Now this was something about series parallel combination. Now there comes a simple question, and that was asked differently in board exam of 1 mark only. What is the question? Question is that when two resistances are connected in series, their equivalent is 16 ohm, but when connected in parallel, their equivalent is 3 ohm. Find each resistance. Find each resistance. है भाई? तो simple question. I used to tell this question every time, every year, but paper setter asks this question differently. How they ask in 1 mark question? If a student has two resistances, two conductors, and he can obtain resistance of 3 ohm, 4 ohm, 12 ohm, 16 ohm using a single one or using two. What are the two resistances? Like that, 1 mark question. The student who had the knowledge of these two digits could do that directly without any solution. So here R1 plus R2, 16 ohm, 1 upon R1 plus 1 upon R2. Students commit mistake here. They write series 1 by 3. You can series equivalent is 1 upon R. So from equation 1 to R2 equal to 16 minus R1. Putting this value here, 1 upon R1 plus 1 upon 16 minus R1 equal to 1 by 3. LCM comes R1 into 16 minus R1, then R1 16 minus R1 or minus R1 plus R1 equal to 1 by 3. So you get here a quadratic equation 48 equal to 16 R1 minus R1 square. Or you can write here R1 square minus 16 R1 plus 48 equal to 0. 12 4 ja 48. So you get here R1 equal to 4 ohm or R2 equal to 12 ohm. So it means two resistance are, if I take R1 16 and R2 4 ohm. So the values are 4 ohm and 12 ohm. हाँ भाई, तो if we use single resistance 4 ohm, we can obtain 4 ohm. If we use 12 ohm, if we connect them in parallel, we get 16 ohm. If we connect them in, if we connect series in 12 ohm, 16 ohm in parallel, 3 ohm. Thank you.